Much of the time in business analytics, we talk about values that are deterministic. They're just one value. They do not waver. It is just a known commodity, and that's what we put in there. However, the truth is a lot of times out there that what we're looking at is a variable that we have an average, we have a standard deviation. So there is this stochastic piece to it where the world changes. And the way that the world changes oftentimes really affects the outcome that we're looking for. We're going to use example 16.6 out of the Jagia et al. Business Analytics textbook. And when you look in there, there's a scenario where Abigail is trying to determine the number of tailors that she wants to employ so that she can maximize profits. Again, profits are associated with revenue. So in this case, Abigail has tailors who make jackets. So profit is the revenue, which is going to be the number of jackets that are made times $50. And then we have to subtract away the costs. Costs are a function of overhead, the wages based on the number of tailors that she has, and then also the cost to make each one of the jackets. So I've gone in here right now. I need you to open up the file that's called jacket XLS. You will need to put in the values for the selling price of the jackets, overhead cost, and the tailor's wages in there. And then before you jump into making this stochastic, what I have done is if we said, based on the data, that the average demand is $139, 139 jackets a week, that the production rate per tailor is 36 jackets per tailor, and the material cost is $12 per jacket, we could go through and calculate deterministically the amount of profit that would be made for having 1, 2, 3, 4, 5, or 6 tailors. And the way we do that is, again, when I'm looking at the profit is the selling price times the minimum, okay, the minimum of either the demand that week, all right, or the number of jackets that can be produced, right? So we can't sell more jackets than we produce or than what we demand. So the cost of a jacket times the minimum of that value, and then we need to subtract away the overhead cost. Okay, overhead cost always remains there. Then we need to subtract away the amount for the tailors. This is the wage per tailor, and this value here is the number of tailors that we have. Finally, we need to subtract away the cost of each one of the jackets. Now, your textbook has this part of the equation incorrect because, again, it's going to be the cost of the material times the minimum of whether it was the demand that we had each week or the number of jackets that was created. Again, that's an issue with the textbook. This is the correct equation. All right, once we get that in there, we can left click and drag all the way across, and we can see from a deterministic model that we should go with 100 or go with 4 tailors because that gives us the maximum profit for the week. However, let's also go back and say, wait, we know that demand is not 139 each month. We also know that the number of jackets that a tailor makes in a week is not always 36. And then finally, based on our supply chain cost and everything, the cost of the material also changes each week. So what I'm going to do is I'm going to go in and change the demand to a stochastic variable. So if you go to data analysis, again, if you don't have the data analysis there, add the tool pack, go to random number generator, click OK. The textbook tells you that for the weekly demand that it's only one variable that we're putting in there. We need 100 random variables. It's a normal distribution that the average is 139. However, 14.61 is the standard deviation. Okay. Excel also needs, for random number generator, it needs a seed. Okay. You can put any number in here to get started. I'm going to leave it as 1 so that what I put in is what you put in, what you will also get as well. Again, I know it's supposed to be random. Excel has to start with something to get things going. So I put 1 in. If you are using a Mac, your numbers are not going to look the same because it's coded just a little bit differently. And then finally, we want our output range to go in this demand column. So that's L11. All right, everything's here. I click OK. It says it's going to overwrite. I click OK. It puts in now for me 100 different variables, random, based on the normal distribution that I just had. Okay, next. Production rate per Taylor. This is again, we're going to do a random number, but on this one, it's uniform. Uniform is like if you had a six-sided die, the chance of 1 coming up is the same as the chance of 6 coming up. And again, in the way that this is set up, they're saying that there's just as likely a chance that they'll produce 31 as they will 32, all the way up to 41. Okay, so that's what's going on here. We're going to change our output. We need this to now go to M11. And then finally on the material cost, random number. This is also normal distribution with mean of 12, standard deviation of 1.37. We need the output to go to N11. All right. Now we've generated over here 100 different demands, 100 different production rates, and material costs different for each one of the weeks. You'll see that we have lots of decimal places here. We don't need all these decimal places whenever we're looking at the actual production. As a matter of fact, we need to round these numbers. So over on the left side, what I've already done is I'm saying equals round this variable, all right, this value, and I want it rounded to 0 decimal places, right? It makes sense that we're going to have a demand of 95 jackets, not a fraction of jackets. Production rate per Taylor, again, we're taking the production rate, random number, we're rounding it down to 0 decimals. And then finally on the material cost, because it's a dollar figure, we're taking the random number and we're keeping it at 2 decimals so that we have dollars and cents. All right, with that, I'm going to left click, add all of my data in, add all of the scenarios in, and then we can go from here and say, okay, now based on a stochastic setup, where were we? What does this really look like? If I take equals the average of the 100 different scenarios, and in the scenario what I've done was I've taken a random number for the demand for that week, a random number for the production per Taylor, and a random number for the material cost. So it could be any week, any kind of scenario that pops up. I want to take the average of all of the weeks where I just employed 1 Taylor. All $135 loss. I want the standard deviation. This is a sample, so it's a stdev.s. I want the best case, okay? Now that's the max, right? It's the max of all of our values. And then finally, worst case is min. All right, from a stochastic standpoint, this is what it says. If I only employ one tailor, the average loss that I'm going to get is $135 a week, all right? However, it could be, just based on the randomness of the variables, it could be as little as about $38 or almost as much as $238. So let's go ahead and take these values now, or these formulas, and let's stretch them across. This starts allowing us to see that, again, what we had from a deterministic model from before, we showed that having four tailors gave us the highest amount. We've run a simulation now. Nothing has changed, right? 4 still is the right, or still is the answer that Abigail should go with on the number of tailors she should be using. However, the truth is that even with 4 tailors, that there are weeks where she will make only $400, or she could make up to $2,248. All right, look over here is just a change. The way that the simulation also said that if I only employ 3 tailors, my worst case scenario really, I mean, it's higher than the worst case scenario for having 4. So depending on your risk aversion or whatever else, you may say, well, wait a second, if I employ 3 tailors, then I have a better chance of not losing as much money, but I may not make as much money. Again, going with this stochastic allows us to see a wider range of what could happen in a scenario. So this is all you need to do for finishing off the scenario this week. Get it to this point and then get ready to upload it. Thanks.